Inspection of installed ANSUL bladder tank system. To begin the inspection, first you need to carefully check the following list of components of your ANSUL bladder tank system. The bladder tank, the sight gauge, the proportioner, the hydraulic concentrate control valve, the associated piping and trim. Next, make sure to perform a general inspection to ensure that everything is installed properly.
Well, Jerry, on this particular system at ANSUL, it looks like we have 5 deluge zones. These are protecting the truck and rail car unloading facilities. We have the rail car middle zone, rail car north side, tanker truck north side, rail car south side zone, and finally the tanker truck south side zones. And the deluge zones are all being fed by a between the flange 6-inch proportioner feeding the 5 zones. We have a hydraulic actuated foam concentrate valve, and on the hydraulic actuated foam concentrate valve we have the sensing lines that come off of each one of the alarm trim on the sprinkler valves, with a check valve in each one feeding a common 3/8-inch copper tube manifold that's running up to our hydraulic actuated valve. In the foam concentrate line, we have a main isolation, concentrate isolation shutoff valve, our hydraulic actuated valve, and then a standard swing check valve to prevent water backflow from getting into the foam and diluting the foam.
I see you have 2 tanks here.
Yeah, that's interesting. Actually, we have 2 tanks that had to be manifolded together to give the required capacity. Initially, when they were looking at the design, I think there were only 3 or 4 zones, and then they added the additional zones that required manifolding a second 400-gallon tank in with the 1,000-gallon tank. So we're actually discharging foam agent out of both tanks simultaneously.
Okay, all right.
Inspection on it looks like everything's installed in accordance with plans and specifications. I think we're probably ready to begin filling.
Okay, sounds good.
The next step is to stage the appropriate foam concentrate. Check the foam concentrate to make sure it's both the correct foam and amount of foam for this particular application. Prior to adding any foam concentrate to the tank, its refractive index should be measured and recorded on the field inspection record, along with the refractive index versus concentration curve. The procedures for these operations are covered in the field inspection manual. In addition, it is also required that the batch numbers from the concentrate containers be recorded on the field inspection record for future reference. Now that you've carefully completed these instructions, the inspection is complete and the ANSUL bladder tank system is fully operational.
If you're involved in filling a bladder tank or installing a bladder tank, it's important to refer to the ANSUL manual. This is the vertical and horizontal bladder tank manual. Inside of the manual are the detailed procedures that you form for filling the foam system, which involves step-by-step procedures that we're covering here in this video. There's also a fill measurement guide to this manual. The 2 of these manuals are shipped with each system from ANSUL. The next thing is involving threaded connections where you're going to have foam concentrate. Number 1, galvanized pipe should not be used in contact with foam concentrate. So it should be Schedule 40 black pipe. possibly some type of stainless steel or brass, or it might be required on some projects, but Schedule 40 is acceptable. On threaded connections, it's important that you use a high quality Teflon tape. You'd apply the Teflon tape over the thread, and then for best assurance against leaks, in conjunction with the Teflon tape, ANSUL recommends this particular type of anaerobic pipe thread sealant compound. This particular sealant is called Permalock. It's manufactured by Permabond International, and it's called Permalock LHO50. The reason that's important is because some types of thread sealant compounds that you would use normally for water service, the foam concentrate will dissolve the thread sealant. So with this type of compound, you do not have that associated problem, and you do not have those problems with leaks in the concentrate piping.
Filling equipment. When performing an initial fill, a minor or major refill for our ANSUL bladder tank, you must first have the correct equipment. First, you'll need a wet-dry shop vacuum with a 2 horsepower motor or larger. In addition, you'll need appropriate pipe fittings and duct tape to connect the vacuum hose to the 1-inch NPT tank shell vent valve. Finally, a concentrate fill pump capable of 25 GPM maximum output at 15 PSI, 1.03 bar, a pump suction and discharge hose, a 2-position ball valve, and all appropriate fittings for connecting to the 1-inch NPT bladder drain fill valve. Now that you have all of the recommended items just mentioned, your ANSUL filling equipment for initial filling, minor and major refilling is ready to be deployed. Initial fill for bladder tank. Before you proceed with the initial fill, ANSUL recommends performing a complete inspection of the ANSUL bladder tank system. Once inspection has been completed, the following steps will help you to initially fill our ANSUL bladder tank. Keep in mind that on a new system, you'll need to prepare the bladder tank for its first fill. First, remove the plastic shipping plugs from all of the bladder tank trim valves. Make sure the bladder tank valve handles are in the following positions: water inlet valve, closed; tank shell drain valve, closed; bladder drain fill valve, open; tank shell vent valve, closed; bladder vent fill valve, open; concentrate isolation valve, closed. If provided, make sure the sight gauge valve is operating. Next, connect the vacuum hose to the tank shell vent valve by using pipe fittings and securing it with duct tape. Now connect the vacuum hose to the shop vacuum and start the vacuum. Note the high-pitched sound from the vacuum before opening the valve. This will be the same pitch heard in the steps to come. Now open the tank shell vent valve to pull the air out between the bladder and the tank shell. As soon as this is complete, close the tank shell vent valve, then turn the vacuum off. Now open the concentrate pump valve and prime the pump with concentrate. Then close the pump valve.
Before we start filling these two bladder tanks that we have behind us here today, we're going to discuss the type of foam concentrate pump that should be used for transferring the foam liquid concentrate from the drums and into the bladder tanks. The type of pump that's recommended is a centrifugal pump. This is a self-priming 26 gallon per minute utility pump. It's driven by a 3/4 horsepower motor and it's direct coupled to the pump. You can buy this as a kit from ANSUL that includes the clear discharge hose, the fittings and valve, and the hard rubber suction hose. The reason it's important to use the right type of pump is some pumps do not transfer foam concentrate at a sufficient high enough rate. This particular pump is basically high volume, low pressure. You should never use a hydrostatic test pump for filling foam tanks of any type because you may overpressurize them accidentally. On this particular arrangement, then we have a pickup tube. At the end of the pickup tube, it's cut at a 45-degree bevel. So when the pickup tube is inserted into the drum, it does not come close contact to the bottom of the drum. So we don't have a problem with picking up the liquid through the suction hose. It has a fuse switch connection on it and an extension cord that we connect up to a 110 volt power supply.
Next, connect the pump to the bladder drain fill valve. Keep in mind, only the ANSUL foam concentrate specified on the tank nameplate may be pumped into the bladder. Now it's time to start the concentrate pump and open the pump valve. Proceed to fill the bladder tank with the ANSUL concentrate. At this point, the only valves that should be open are the pump valve, bladder drain fill valve, bladder vent fill valve, which is venting the air being displaced by foam concentrate. Once the bladder tank is filled to the rated capacity stamped on the tank nameplate, close the bladder drain fill valve. Shut off the concentrate fill pump and close the bladder vent fill valve. Now disconnect the vacuum hose from the tank shell vent valve. Disconnect the concentrate fill pump from the bladder drain fill valve. If an optional sight gauge is attached, take a reading and mark the full level on the sight gauge tube. Venting off air in bladder. After filling of the bladder tank with foam concentrate and prior to commission flow testing of the system, ANSUL recommends that any remaining air in the bladder tank be vented off. This ensures that foam agent is available up to the foam concentrate outlet of the tank to ensure rapid response of foam concentrate reaching the proportioner or proportioners in the system. To do this, very slowly partially open the water inlet valve with the tank shell vent valve open in order to vent air from the bladder until all of the air is vented from the tank shell and water appears from the tank shell vent valve. Make sure both the foam concentrate isolation valve and the hydraulic actuated concentrate valve are in the closed position prior to doing this to prevent loss of foam concentrate in the bladder tank. Close tank shell vent valve and carefully proceed to partially open the bladder vent valve until frothy foam concentrate appears at the bladder vent valve. Do this with caution, standing ready to close the bladder vent valve immediately so as to not spray foam concentrate over the tank or the person standing watch at the valve. When frothy foam appears, quickly close the bladder vent valve. Now all the air has been vented from both around the outside of the bladder as well as internal to the bladder. At this point, the water inlet valve can be turned to the fully open position. Be sure to rinse any foam concentrate off painted surfaces. At this point, you're almost through with the initial fill procedures for ANSUL's bladder tank. The next step is to return the bladder tank valve handles to the following operating positions. Water inlet valve, open. Tank shell drain valve, closed. Bladder drain fill valve, closed. Tank shell vent valve, closed. Bladder vent fill valve, closed. Concentrate isolation valve, normal operating position. If provided, sight gauge valve, operating. Insert the ring pins through the valve handles into the brackets and install the visual inspection seals. To give maximum assurance that the system will operate effectively and safely, a maintenance examination should be performed at this time. Finally, record the date of placement in service and instruct personnel on operation of the system. Now that each of these steps has been carefully completed, the ANSUL bladder tank is successfully filled for its initial use and operation. Flow testing bladder tank with test header. Prior to the testing, make sure all valves on the bladder tanks are in the correct positions. All 1-inch, 2.5 centimeter vents, fill and drain valves should be closed. Hydraulic actuated concentrate valve should be closed. Concentrate isolation valve should be closed. Once these precautions are taken, slowly open the water inlet valve to pressurize the tank. Now connect the hoses to the test header.
Okay, so I think I got a table here, all right, and I think we got a 2.5-inch nozzle in there right now. There's nothing restricting it, right? So we'll just read the pressure, and if we get it up around close to 500-600 GPM, that's fine. Wouldn't even have to be that high. I mean, we could, because this is a low flow proportioner. This thing would proportion foam even if we're flowing a couple hundred gallons per minute. But if we get around, you know, I'm not sure what we're going to get because I know the fire water pump's on and on, but we'll just see what we get, see if we get a pressure reading on it. We can increase or decrease the valve a little bit to where we want to be. Once we get it set, then I'll just radio in for it to turn the foam on, catch my samples. As soon as I get my foam samples, I'll just radio back. We'll shut the foam valve off in the foam tank. We just flush the lines with water. And we're all done. Okay. Okay.
Prior to flowing foam solution, the water flow through the test connection needs to be checked to ensure it is in the acceptable flow range for the proportion or size being tested. Once that has been verified, you are now ready to test with foam. This is best accomplished with the use of two-way radios or cell phones.
Above 5. A little bit above 5, right? Okay, we got about, I think that's good right there. We got about 8 psi or so. We're a little bit below the target, but we're probably going 400 or 500 gallons per minute.
Once you've established the required flow through the test connection, the person taking the foam solution sample should radio the person back at the bladder tank, instructing them to open the foam concentrate isolation valve. This might require them to be positioned on a ladder to access this valve so they can open it promptly and then close the valve after the foam solution samples are taken.
Okay, Jerry, open up the foam valve.
When you've established a flow of water through the system through the sprinkler valve and the riser, the person at the bladder tank must observe and verify that the hydraulic actuated concentrate valve operates properly to the open position.